So now, before we get started, I would like to introduce your speaker today. He is John Casadante. He is Product Marketing Manager at Cree. He is a marketing leading innovator of lighting class LEDs, LED lighting, and semiconductor solutions. With over 20 years of technology marketing experience, John leverages his knowledge and understanding of vertical markets to address the technical, operational, and business benefits of LED lighting. In John's current role at Cree, he drives thought leadership to the participation of many conferences, trade shows, and webinars like we have today. John also works closely with agents and end customers to choose the correct product for them and to stay ahead of market development trends. So with that, I will hand it over to John, and he will talk about industrial LED lighting and what that means for facilities managers. Hi, John.
Thanks so much, Ann, and welcome everybody. Thank you for attending this afternoon. I hope that what you're going to find in this presentation is, if you're new to the topic, a little bit of education and positioning, and understanding of the places where you would consider to use LED lighting for high bay applications. And for those of you that have been appraised of this situation in the past, hopefully you'll hear some new information that will draw you nearer to making the decision of whether you should go in this direction or whether you sit tight with your products that are currently installed. So first, I always like to do a level set on the products and the positioning of where we're talking about in terms of high bay lighting. This is a definition that's developed by the IESNA, and essentially, if you look on the right-hand side, you see two different graphs, or two different placements of graphs. You have what we refer to as a low bay product, which is anything from floor level up to 25 feet. The high bay level is 25 feet and above, and clearly the graph on the left-hand side shows 60 feet, but clearly it can go even higher than 60 feet for any application that might be a warehouse application and or, you know, a set of open warehouse space or manufacturing facilities. So, you know, as you hear the presentation again, think of yourself in this placement of whether you're below 25 feet or above 25 feet, and we'll cover the topics. So what are the typical high bay applications? And I want you to kind of consider each one of these pictures. And when you look at it, instead of just identifying the fact that it's a different location, different marketplace, consider the atmosphere, the temperature, the climate situation that might occur. Consider what kind of difficulty you might have to manage when it comes to maintenance, understanding the different types of light that actually can be produced. Some of the ceilings that you can see in your picture there are darker, some are lighter, and we're going to talk to those details in a little bit. Something else that you want to consider as you identify your application in the space or your marketplace is whether vertical light is critical or whether the kind of clarity in the light is more critical to your specific needs. So many different types. Obviously, if you look from top to bottom, manufacturing all the way through concourses, sports facilities are becoming really popular in the discussions of high bay applications. For those of you that are sports fans, and especially indoor sports fans, whether you're college or professional sports, there are different requirements to address the needs of those indoor facilities. And there are also different strategies when you're dealing with warehousing space, when you see aisles with tall shelving, or if you have wide spaces, wide open areas. So as you think about questions, again, consider what are these locations and what the most important items are to you. Let's talk about, in general, what high bay lighting means to North America. And this is a simple graph that comes out of a research facility called Navigant. And if you see the total number on the bottom right-hand side, just a really super large number of products installed in this particular area. And the breakdown on the left-hand side shows you anything from industrial all the way down to transportation. This generally is a good topic slide for the manufacturer, but I think it also is a good way to translate to you the just huge, huge installed base of products that have happened over the years, certainly beyond my years of life, possibly beyond many of yours. Some of these products that have been installed for over 20 to 30 years are still effectively doing a job, maybe not the correct job, but still lit and, you know, still providing services. But we're going to give you some incentives and some thoughts to think about as you want to consider LEDs for some of these applications. So let's talk about the existing and incumbent technology that might be found in many of your installations. On the left-hand side, we have metal halide. On the right-hand side, we have fluorescent. There are different styles of both those options. One is a probe start metal halide, one is a pulse start. For the purposes of this conversation, just consider metal halide all in one. On the right-hand side, you might actually see a difference between a T8 linear fluorescent lamp and a T5 high output linear fluorescent lamp. The type of products, type of actual fixtures you would see these particular light sources being installed in are shown on the picture. There on the left-hand side is your very common high-bay fixture. Typically, we see these in just about every installation. If you walk into a high school or a college stadium, you're going to see something that looks very similar to that. On the right-hand side, you see more of a linear application. These linears are definitely found more in the manufacturing facilities and a lot of warehouse facilities. They generate quite a bit of light. Of course, the installation is a little smoother, a little cleaner on the ceiling. Sometimes they're suspended. A lot of times they're actually mounted flush against the ceilings. So again, these are the incumbent technologies we typically see in the marketplace, and these are the technologies that we apply our LED strategies against. So think about Haibane. Let's think about specifically metal halide, and when we deal with topics like shortcomings, understand that for the most part these lights have been very effective for many of us over the years. Certainly before I even joined an LED company, these lights have been in places where I've worked and have performed extremely well. But there are some things that we need to consider if we have metal halide within each of these places. Number one, from an efficiency standpoint, they eat quite a bit of electricity. Not generally a thought that we had years ago when we really didn't have many options, but today when we look at the comparison of what can be offered and what's available at that time, efficiency is a really deep shortcoming in this particular category. Lumen depreciation. So what that refers to is the amount of light that's left in a product that is burning for several thousand hours. It might even turn into years. Again, the light may still be producing enough visibility for you to do some work, but in comparison to when that product was actually installed, it's greatly deficient to what we would remember as initially doing the installation. Color shifting. Sometimes this is very easy to identify. If you are in an open space, next time you walk into, let's say, an airport concourse level, take a look at the ceiling and just kind of keen your eyes on the different types of lights shining through. If it hasn't been recently updated, you'll probably notice some different colors actually shining through those lights. That's pretty typical, and sometimes it's not as obvious, but it is affecting some of the performance of the individuals underneath. And we'll talk a little bit about how color temperatures and color rendering do affect many of us in our normal day-to-day lives. Shortened life. This is really key, especially when it comes to maintenance issues. So when you have a product that has a short life, 8,000 to 10,000 hours, you probably have a plan. If you're a facility manager or part of these organizations, you probably have a plan to do relamping at certain periods of times. Sometimes the relamping process might be upon failure. Sometimes relamping might be after a certain number of hours. And what this actually ends up producing is a cyclic process where you're constantly up in the air, either on a ladder or on a lift, and you're either shutting down the operations of the business for a shortened period of time in order for that maintenance to actually occur. So a shortened life is not a very strong suit for the metal halide product line. Startup and restrike times. So there are many examples here that we talk about. So power outages. As Ann mentioned, you guys are experiencing a storm. There might be situations where the lights will shut down and turn back on. Metal halides have a really difficult time of regenerating their power up to the levels that it needs in order to provide the light. If it takes a little time to do that, your workers or your processes are basically shut down for a period of time. Some of the most common examples are if you ever walked into an arena and lights are shut down, or if they're trying to establish some kind of imagery on the court, they can't effectively shut down those lights because they have to wait till they warm up to turn on. It could be tens of minutes before anything actually happens. So they end up using shutters across those fixtures in order to effectively do the whole shutdown and turn on process. So startup and restrike times really, really detrimental to this product family. Also, they don't work well with controls. So how often are we now talking in the industry about implementing controls? High bay controls are not common, but they are beginning to turn up more effectively on products that can accommodate it a little easier, like an LED. Being able to dim down and not shutting off lights altogether, but still providing enough adequate light for jobs to occur and still save a lot of money in energy costs. Another option is the light levels themselves. So over time, as we mentioned, the lumen depreciation turns basically into a problem with light levels. So when you first do your installation and you meter it and you see that you're getting 35, 45, 50 foot candles of light, over time that actually is going to adjust pretty rapidly, and you might fall well beyond what you typically would need for the job and the performance needed. So taking that into consideration, light levels are a really key item, and again, that also reflects back to maintenance and whether you relamp earlier or later within the product family. And I think lastly, what it's showing here is health and safety. So think about the kind of products that you're using. There's mercury content in metal halide bulbs, and also from a dispensing standpoint, if you have to actually throw these products away, you're required to do it in a special fashion. You might have to have special containers. You certainly have to provide or deliver them to a special facility to actually consume the mercury products. So that could add to the cost and the overall maintenance of your environments. So let's look at the fluorescent high bay. So same kind of strategy, thinking about shortcomings of the product. Number one, poor optical control. You guys know that when you look at a fluorescent lamp, it's one purpose in life. It's linear. It's going to glow. It's going to actually want to use reflectors in order to broadcast the light as best it can. That's typically not ideal, but it has been effective in the past. Its lifespan is also very shortened when you recycle it, meaning when you turn on and off. Again, probably really recognizable if you have a fluorescent light in a shop or in a garage. You turn it on. Sometimes it flickers, comes on quickly. Sometimes it might flicker and kind of dwell a second or two and then come on. And every time you recycle powering on and power off, you're basically eroding the product or limiting the product's capability of coming back. Size of the product, right? So typically you're looking at either 4-foot or 8-foot length linear tubes. That is very specific in terms of where you can place those particular products. If you're in an aisle, that's probably a no-brainer. They work pretty well. In an open area, your broadcast of light is going to be very unique, and it's going to require more fixtures up in your ceiling in order to deliver the complete levels that you need, a consistent light level across all your areas and spaces. Fluorescent also has a health issue in that it also contains mercury. You have the same recycling issues. These bulbs often do fall, creating problems. A lot of people don't realize that you don't want to sweep or even vacuum a linear bulb or any kind of mercury-filled product, because that creates all kinds of health issues around the board. And let me talk a little bit about performance sensitivity in temperatures. So one of the things I neglected to mention on that very first slide as we were looking at it is that typically when you have high heights, you're dealing with various temperatures. When you're in various applications, you also are dealing with various ambient temperatures within your space. Fluorescents are known to perform at a fairly high rate at low temperatures after warm-up. So if you look at the graph, I'm actually doing a click here, and you're going to see that optimal performance for a T8 32-watt linear bulb, linear lamp, is around 32 degrees Celsius. The more improved T5 high output actually performs best at 35 degrees Celsius, actually at the warmer temperature. So the warmer the temperature, the better the fluorescent lamp will provide. Lower temperatures, think of cold storage, not really an ideal situation. I can give you a firsthand experience of my situation with fluorescent lamps. I have a barn. It's fairly cold these days. When I turn on my, when I had turned on my fluorescent lamp, I would have to wait almost 10 to 15 minutes before we get up to temperature in order to provide enough light for me to actually do some work. And I'm sure that's the case of many of us that are dealing with these in our spaces. Lumen maintenance, specifically LED lumen maintenance in lifetime. So graph really tells the details. If you look at the different types of product, illumination products, metal halide, fluorescent, high pressure sodium, and LED, you can see the graph is really telling that an LED product is designed for a long life. Long lives mean anywhere in the range of 50,000 up to 100,000 hours. It's considerably better than what we would ever expect from any of the incumbent technologies. Also, if you look at the number of lumens that are being produced at that given time, lumen output is fairly high for LED, even over a length of time, let's say over 50,000 hours. If you look at the 70% range, there is a number that the LED manufacturing world review. It's an L70 number, which tells us that that is really the length of time that we envision the LED to be at optimal performance. Anything below that L70 number means that it's potentially identifiable for an upgrade or for a replacement, but it's still considerably longer in hours, anywhere up to maybe 20,000 hours longer than a standard incumbent technology product. So some fun statistics. This really doesn't change very much. I know most of you probably see it, the 2011 Building Energy Data Book Review. The latest one is really slightly different, and what you can see here is energy use on the left-hand side, energy expenditure on the right-hand side, and what should stand out is lighting is very predominant in both cases. On the right-hand side, I do want to point out something for those of you that manage big buildings. Know that heating and air conditioning are largely lumped together when you consider your overall expenses. So we completely understand that that's probably your number one expense within your building spaces. But lighting should be close to number two, if not number two, in a lot of your environments. And again, this tracking from 2011 up to 2016-17 is pretty identical, and really is a telltale sign that we're still pretty much using so much energy just to provide light within our industrial spaces. So why change to LED? And it just really pulls a little bit more detail off of the past slide. So if you look at the graphic, you're seeing basically the total CO2 that is emitted from lighting versus the percent overall based on the other spaces, and it's a big abuser. So anybody that is really focused on environmental concerns or sustainability plans within your space, you'll know that lighting does produce a lot of problems for us in the environmental industry, and it does consume more energy than what we would want to have. So how can we effectively make that better for all of us? We look at it one way, it's just changing to LEDs in the high bay range. So a couple things to look at. Energy savings. So the commercial electricity prices, as you can see on the right-hand side, the graphic is illustrating anywhere from 8 cents within the last 20 years, 15 to 20 years, all the way to roughly an average of 11 cents, maybe a little bit higher in some locations, maybe as high as 12.5% in some locations. But energy savings can be as much as 85% in a couple different ways. One, just by the sheer product, and two, if you implement things like lighting controls. Those are two ways of actually generating a huge amount of savings. Why LEDs? Again, long life. Long life means less time actually doing any kind of maintenance within the field, less time hiring somebody to actually come and do the relamping, less downtime for individuals that actually have to roll in lifts or ladders, and certainly a less of a security concern, health and safety, I'm sorry, not security, but health and safety concern for individuals that are operating underneath these spaces. So big, big plus when it comes to long life and your energy savings. So heat removed from space. Now this is an interesting one because many of you that are informed might say, well, wait a minute, LEDs do produce heat. And LEDs can produce quite a bit of heat depending on light output coming from those fixtures. However, the way that the products are designed is that there are ways to dissipate that heat into different directions and actually make that travel, let's say, vertically as opposed to underneath the fixture. When the heat travels vertically away from the light source, your light source itself is going to have a longer lasting time. The heat travels north, it's going to stay up at the top of your space. It's not going to drive any heat down towards the floor. Hopefully that will reduce your heating and air conditioning over time. More of the air conditioning, as far as heat dissipation in the wintertime, that either can, evacuate from vents coming from the top of the ceiling or fans pulling those directly across the ceiling to an outdoor location. So really, in the design of an LED, you're looking at a much better designed product in the product that is pushing heat away from its light source instead of delivering the light source and also pushing it downward. This bullet should not be taken lightly. Superior optical control. You heard me mentioned earlier that when you're dealing with fluorescent lamps, largely you have little control of how you actually display the optics or display the light going from the actual light source through the fixture. You might have some reflectors that help that cause. LEDs have so much better of a way of controlling light. You can buy optics that go over top the LEDs on a per fixture basis that will determine the amount of degrees the light will shine, whether it's straight down, whether it's a broader angle, whether it's more of a globe-like environment, whether it's more linear. So you have all kinds of flexibility of selecting your optical broadcast based on a per product selection. Controllability. So the big plus for LEDs is that they respond really remarkably well to controls. You can dim most LED fixtures, even high bay fixtures, at a pretty decent rate. You can also make those susceptible to things like vacancy and or daylight harvesting, so where you can actually leverage outside light and use less of your broadcast light within the building, and the LEDs have the abilities of sensing and making those alterations a lot easier than any of the incumbent technologies. Another factor is Lumen Output. So you can selectively buy a product that matches the Lumen Output you require. 35-foot candles on the floor, perhaps you can get away with 18,000 lumens depending on the height of your ceiling. If you're at a higher rate, maybe 65,000 lumens is what's required if you're really high up in the air. So you have those options of matching it. Typically when you buy an incumbent product, you might have to marry multiple products together just to get enough lumens that are broadcasting to the floor to get your levels up to a safety level. Better light quality. So if you are new to the LED discussion, one of the benefits of LEDs is its color rendering capabilities. And largely that's driven through a palette of colors that are referred to within the industry based on numbers, like an R9 number in this particular case is an indication of how much red actually shows up within your light pattern or your light wave coming down, your light wave coming down from the fixture. So better light quality, what it translates into the ability of actually identifying things a little easier. If your job on the floor is to do assembly, and you're assembling products that might be color-coded for simplicity, for those of us that are gaining in age, it is certainly a lot better to have better quality light to do your job. Poor light can turn into problems, and problems turn into costs to the company and possibly returns that can affect you pretty negatively over the long run. And finally, no mercury. No mercury within the LEDs, so you don't have the issue of having to replace or actually having a designated area to actually recycle these products. They're actually considered to be solid-state electronics. They get recycled just like any computer technology product that might be offered. And what we're going to show you in the coming slides is your payback opportunity by using LEDs in the high bay applications. So really simple, looking at this, why change to an LED? Very typically 400-watt metal halide light up in the ceiling. That's what we typically see. our equivalent or the industry's equivalent LED light is roughly going to be around 240 watts. You can see that we don't change anything relative to the operating hours, but we do look at the amount of electricity that's being consumed, and you can see that's nearly 50% savings just on the electricity alone. The amount of CO2 that is actually pushed at that particular time is roughly half. And you look at the number of tons, both in terms of nitrous oxide, is also half. So everything basically at 50% energy all the way down to any kind of emissions. So translate that into actual real numbers, you're looking at potentially up to $100,000 in lifetime savings, both energy and maintenance. The energy side of it is what we illustrated a little earlier. The maintenance is something you have to calculate on your own, based on your own recycling of product, how many times you replace a bulb. But these are very conservative numbers. We have situations, the industry as a whole have really good reference points to where we can illustrate that LEDs are just really a no-brainer in terms of movement. Paybacks are not always going to be a 1.1 years, but if you look across the board, you're probably looking at less than 2 years on average for any installation for a Haibane product using LED. So let's give you a quick look. Hopefully your screens are illustrating this as properly as they should. So your image shows two different light sources, one left, one right. The light source on the left is a product with low CRI. Product on the right is a high CRI product. As I mentioned earlier, LEDs deliver very high CRI, color rendering indexes. So what you see on the left-hand side is potentially a really dark red border around the cord. The reality is that cord actually is really a bright red, and that bright red shows a lot cleaner. If you look even more carefully at the floor, you can see the difference in the actual wood layout. Lumens can see the actual grain layout on the right-hand side versus the left-hand side. So why is that important? Again, if you're in an environment where you actually have to read things, whether you're reading something printed in black and white or in color, or if you're following some kind of process that color is involved, it is almost critical to consider LEDs just for that reason, just so that you can actually get a better idea of how you're managing the product and the services or the system that you're operating with. So again, looking at the pictures, you also have to think of it from the standpoint of your employees or from customers. If you're a sporting facility like this, you basically want people to get a better feel for the overall product on the floor, and that certainly will shine no matter whether it's the floor or the uniforms the individuals are working in. If you are in a business environment, a higher CRI actually translates to people actually feeling a lot more alert. Lots of statistics that are shown that people operate under a more cleaner type of light, a more sun-like type of light, are feeling better about themselves and tend to be a lot more awake for a working day. So hopefully that will translate also to less incidents that have to be reported in your particular business spaces. So temperature. So these are things that have to be put into consideration, like I mentioned earlier. So really the question is, do you know the temperature in your ceiling? I trust that some of you actually do know the temperature in your ceiling. If you're in a facility that's doing any kind of metalworks, you probably know that you're in the 60 degrees Celsius range, and the products that you're going to put up in those ceilings are going to have to endure that kind of temperature and continue to operate. You really need to pay attention when you're searching out new products, the operating range of those particular fixtures. Not only do you have to understand whether they can sustain heat within those temperatures, but you're also going to have to get an idea of how that fixture is going to perform while it's sitting in that temperature. Like, are they going to degrade? Is the light source itself not going to be able to produce the amount of foot candles that it originally intended to as the heat increases? So know what your ceiling temperatures are. Look at the statistics, the specifications on your products to make sure that you're marrying the correct product with the correct temperatures in your ceilings. Another question to think about, spacing. So you can see here in this diagram, like I mentioned earlier, optics are wide and vast. You can get optics for an LED light that actually can go very wide angle or very narrow angle. In the case on the very top, think of an airplane hangar. You probably want a very high, wide-angle scenario, so you're covering a larger area, a larger open area. However, if you're in an environment where warehouses and aisles are really critical, you're going to need vertical light, and you're going to need vertical light that is going to go almost straight up and down. So the optics of those spaces, or the optics covering the lights in those particular spaces, are going to be really important. The other aspect of things you have to consider is glare. And glare is much higher when you have a wider angle, a lot less when you're at a sharper angle. I think that's probably understood. If you stand under one of your lights and directly under it, you're probably going to get a bigger glare than if a light is a distance away from you and you're not looking straight up. You probably can have a better angle of looking at things. That's just a really kind of sensible way of considering it. Wasted energy. So the covered area, the crossover between those two particular patterns are actually twofold. Number one, there's a requirement because you want to make sure that you actually have enough crossover to where that your spaces are consistently lit from one side to another. But you don't want to overlap them so dramatically that you're wasting space. In a lot of cases where we go into an industrial space, we're being asked to do a one-to-one replacement of fixtures. That is not always a requirement. We tend to do it based on what the customer wants, but a really correct way of approaching that is to maybe consider a new lighting design to perhaps maybe remove, a dozen, maybe more of your lighting fixtures, which will also reduce greatly the overall cost of the implementation, as well as the energy that is being burned. So again, the message here, the lesson learned is use the correct Haibane light, use the correct optics, making sure that you're meeting the criteria that you originally designed. Have that in your mind when you're going forward. So uplight, often overlooked is that when industrial customers consider, warehouse customers consider lighting in their environments, sometimes they forget about some of the easy things like colored ceilings. Often we walk into a warehouse space that has been recently introduced to a customer. Perhaps they took over for some other company. And one of the things that they realize is that they have really dark cavities up in this space. Well, number one, it might be as a result of the fact that it's not painted. Of course, the color of choice is white. That does the best reflection. To address some of that, though, some of the products that you would be dealing with in the LED world will have the opportunity of actually reflecting light upward. So they'll use special reflectors that actually have clear spaces on the top to give you some uplight to reduce the amount of cavity or dark illumination that's occurring up at the very top. So, lesson learned here is, your lighting designer and the overall environmental control person, as well as the facility managers, should consider all those as factors when you're looking at the light selection going forward. Another factor is warranties, lifetime and warranties. Let's couple all that together. And here's a really easy way of considering this, is that if you are installing or going through the process of considering a replacement of fixtures, you don't want to have to go up into that ceiling more often than you do today. So again, the case in point is you've got metal halide or fluorescent bulbs up in the ceiling today. You're going through a process where you're relamping those at a certain interval, maybe every 2 to 3 years, maybe less, depending on failures. When you buy a product, make sure the product is rated for the set number of years. Look at the details. Look at the design specifications. If the product is warranted for 5 years, then typically what that's going to translate into is the product is designed to last you probably a little bit more than 5 years, and then after that it's going to degrade. And it's degrade probably beyond the L70 range that I mentioned to you earlier, which in most cases will require a replacement of that fixture. The lights will still work after 5 years, but just not at the adequate levels that you need. Of course, when you look at a broader or a longer range of lifetime or warranty, you're looking at a product that is geared towards a higher number of hours of operation. You're probably dealing with 75,000 to 100,000 hours of operation. And again, it's a choice that's going to be made. There might be factors of price that are associated with that, but you weigh in all the components, your cost of maintenance, cost of disposal of all the other products that you're dealing with, and you should come to a pretty happy number of what you think the real warranty would be for that particular product. So, quick case study here. Same court, looking at the details here, so we'll just kind of continue on. We'll look at the fact that this is a standard basketball court at the high school level. It is Indiana, so we are talking about probably the basketball state, the national state within the United States. The metal halide, 26 metal halide lights illuminating the courts. The lighting levels were at 30-foot candles. Again, another kind of data point here is that know that each of the states have their own requirements for high school, college, professional, indoor sports in terms of light levels. Here we have 30-foot candles. Quite honestly, in the state of North Carolina, that wouldn't cut it. They would be required to do a much higher number, and if it was college, then you're definitely in the hundreds to high hundreds in order for it to actually be, meet the requirements. The other situation, maintenance costs. Products were old, so they were increasingly relamping it on a more frequent basis. The other problem they were having is that they like to do a lot of different theatrics within the space, turn the lights off, have the players run in under a spotlight, turn the lights on. Well, when they needed to choreograph something like that, it was really difficult because then they'd have to wait for the metal halide lights to ramp up. So the solution was an LED solution that was high power, 24,000 lumens. The foot candles doubled, more than twice at 70-foot candles. The CRI was met. The color rendering here still was improved, and if you recall the previous slide that showed the two different color reds, even at 80 CRI for an LED opportunity was ideal in showing, a really solid color rendering of the environment. It was 1-to-1, so 26 and 26 each. The maintenance on these particular products for 10 years, and calculating all the factors, the energy savings along with the maintenance, you're looking at about a 2.5-year payback, and you can see that big, spelled out big on the right-hand side, where not only do you have the savings, but now you have a situation where you have instant on, instant off. So turn on the lights for the crowd to enter in, turn off the lights, get prepared for your team to come on the courts, turn on the lights, and you're ready to play. So summarizing the conversation here, so let's just consider a couple things. If you are waiting to make a decision on LEDs, take into consideration some of the factors that we talked about. Certainly the cost of electricity is pretty much consistent. It's been sustaining itself around 11 to 12%, depending on your territories. If you're in the far south, you're probably not paying at a high rate. In some cases, as warehouse customers, industrial customers, you might have a better rate than the national standard. You might be paying 8 cents a kilowatt hour, 5 cents a kilowatt hour. For those of you that are in that situation, consider just your maintenance costs, because I would almost bet that just your maintenance costs can prove out a swap out to LEDs just for that reason. Consider the immediate savings from the environmental standpoint. Consider the impact on your employees, the safety, the security of your business internally. Also look at the details. Look at the lumens per watt. Notice the fact that you might be dealing with products that are not equivalent to the color rendering that's required for your particular operation. Also consider the space. Are you in an open space, or are you in a very tight space where vertical light's required? You have flexibility with LEDs that you don't typically have with incumbent technologies to actually produce the light where you need it. And lastly, being able to generate uplight and utilizing uplight with LEDs is one of the critical factors, again, using special reflectors to give that sense of broadness or openness within your ceiling. So with that, I think we'll turn it back to Ann. We'll address some of the questions that you might have generated through the call, but I thank you for listening.
Thanks, John. Thanks very much, and thank you, everyone, for listening in and sending in your questions. So, yes, we do have some time for questions, and we do have some that have come in. So, John, I'll start with sort of an application question, and this is, I manage big box retail spaces and warehouses. The ceiling heights are similar. So since these have different functions, should I approach my choice of high bay lighting retrofits differently?
Really good question, because in the retail space, big box facilities, imagine all retail. So in a retail space, you're probably going to want to consider a product, and it very well could be the exact same product look, but it might have a different CRI, and it also might have a different Lumen output. So the answer really is you have flexibility to look at a couple different things. You might elect to do something a little bit different in your warehouse space, considering if it has really tall shelving and you need a lot of vertical light. That might direct you to a different type of optic on your fixture. But in the big box scenario, you're probably looking at a wider open ceiling. You might be able to get a broader wide-angle light, but I would strongly recommend you looking at the CRI of the product so that your products on the floor are actually going to show a lot better and represent your store a lot better.
Thank you. Now, we just had a question come in actually related to that on big sport courts, and you had mentioned the basketball court. So can you just kind of recover or retouch back on maybe some considerations along the lines for sports facilities and lighting?
Yeah, absolutely. So just a little, it might take a few sentences here, but I'll give you a little bit of an ad-lib conversation I've had recently with some of the facilities here. So first and foremost, that sport facilities are actually governed by either the state level, the college. It might be if it's a public college, that also probably has a state level organization looking at it. And then, of course, when you get into the pros, you either have the NBA or other indoor activities that are going on. Indoor tennis, as an example, the USTA might have their own specifications that are required. So those documentation and the light levels are readily available to anybody that wants to look at them. So having said that, high school, we'll take it one at a time. High school is really interesting, and it's a really interesting challenge for all of us in the lighting industry because high school courts are often used for obviously playing basketball, volleyball. You probably have wrestling matches. You probably also have some kind of gathering that happens within those. You might have community meetings that kind of take place in those environments. You also might have school assemblies that are also in those environments. So you take into all those, you take that into the factors. Probably the highest demand light-wise, again, is going to be the sports because it's probably going to require an average of somewhere in the 65 to 70 foot candles through high school. Somewhere in North Carolina specifications, I think it's around that range. Most of the time, and I know life is changing for a lot of places, but most of the time you're not going to see a televised high school game at a facility like a regular, higher ed education building, public school system. So 60 foot candles, 70 foot candles is probably going to be adequate for the most part. When you get into the college level, you're talking about a whole different situation, and I was going to say ball game, but the pun would be too close. And the reason being is that colleges typically are televising. The college dollar for televising any sport now, there's a requirement that you have to have enough light level in order to produce, in order for the television cameras to produce the image in high definition. So in order to produce high definition vision or video, you have to be in the 200, so approximately the 200 foot candles, plus or minus some numbers there, right? But approximately 200 foot candles that will allow you to deliver video to viewers around the country to be able to see that properly. So as you can see, there's a huge jump when you go from high school to college level, and the jump is pretty significant also to pro level. The pro level may be not as high as doubling the range of a college, but you're probably looking at it anywhere in the high 200s to 300 foot candles. That is largely done with a lot more fixtures, though. That's not just one single product trying to deliver a huge amount of candles going down. So installation strategies, where you put your lights, how many lights are envisioned are going to be really the answers that you're going to be looking for. One other piece of information, so the scenario that I mentioned earlier about high schools not only tending to sporting events but also assemblies, there are many colleges that do the very same thing. And one of the colleges that I've interacted with actually elected to do a multitude of lights in the ceiling One set of lights would be turned on specifically for assemblies, gatherings, concerts, and things like that, and a different set of lights would be used for the actual event, the actual sporting event. So it's a much costlier proposition, but that is one of the strategies that come into play.
Great. Thank you, John. Thanks for that thorough answer. Okay, so we have another question about costs, and this is, as I'm sure is common to many of the people on the call, project costs are tightly controlled in development projects. What is the best strategy for convincing owners to spend the higher dollar cost up front for LED fixtures? What have you experienced with your clients?
So I think I'll reflect back on some of my statements. So there have been cases where we've been able to convince people just based on maintenance costs. Those scenarios, though, the scenario for that situation was the individual did not own a lot of its own facility tools and also machines like a lift. So in order to do any kind of maintenance in the building, they would actually have to go to a rental property or rental company and get a lift. They would have to make sure they get all the product in at one particular time to do the actual service. And what I mean by that is that if you had one light that was out within your ceiling, they wouldn't move. If you had two lights, they wouldn't move. It ended up being 6 or more lights would be the determining factor of when they actually do some of the relamping. So you can imagine what has transpired in that amount of time. That might be over weeks, months, probably wouldn't be years, but certainly weeks or months. And in that given time, who knows what might have happened? You might have instigated an actual safety issue that hurt somebody that had to file an OSHA claim, which caused all kinds of issues for that particular company. So, without going into a long, lengthy conversation there, so just maintenance could be a deciding factor. If you can convince somebody to buy these fixtures or buy an LED fixture on the promise that those fixtures would not have to be touched for 5 to 10 years, you're looking at a calculation that just might be just a simple no-brainer for that individual to make. We've also dealt with individuals that have looked at this purely from an energy efficiency point of view. Now, their payback requirements were not as stringent as, let's say, a 2-year payback. They were probably more likely to consider a 5 to a 7-year payback. And if that's the case, then the selling point really is look at the energy efficiency. And, this is not an LED 101 course, but LEDs have improved its efficacy from the day that I began with my company to where we are right now, almost 30%. So considering that, you're going to have a huge amount of savings just on energy and be able to justify it just based on that savings.
Great, thank you, John. Sorry about that. So yeah, we have a number of questions coming in, so I will zero in on some of the technical aspects. What voltage are your lights available in? And I'm not quite sure if this applies to just the sports facilities you were talking about, but there's a question about what voltage are your lights available in, and also amperage per fixture. So if you can provide some general info on that, that would probably be appreciated.
Yeah, sure. So let's just talk about, first of all, voltage. So, as a manufacturer, now I'll answer this with all manufacturers in mind, right? So this is a topic for your education purposes. So we design our products as well as the industry design products to fit into spaces where you already have an existing situation. So building power runs anywhere from 120 to 277 in North America. That's pretty much a standard number. Products are geared to operate that well in that range. Some of the products that you can purchase are self-sensing to the amount of input power that are required. In some installations, there might be a specific requirement for, let's say, 347 volts. That's typically a range that you might find in Canada, as an example. Products are manufactured there as well. They probably are not the exact. In other words, they might be a different model number because that kind of driver, that actual electrical driver, is going to require a different process in order to produce the LED. You got to remember what our products are doing is taking AC voltage and converting it to DC voltage to power the LEDs in order to make the LEDs illuminate. Talking about amps, so really, from an amp point of view, I'm not so educated on that level, but I think we can do this based on simple mathematics and equations. So you're looking at ranges of LED products that go anywhere from 200 volt or 240 watts, not volts, but 240 watts of power up well beyond 400, 500 watts of power that are designed to replace either a 400 metal halide light, a 750 metal halide light, or a 1,000 watt metal halide light. So again, the industry positions themselves pretty effectively in any one of those circumstances, and unless you're really an anomaly, I doubt you'll have any problems finding the right product for your installation.
Thank you. So another question about product characteristics. How can we decide upon the amount of color rendering index or lumens needed for a closed space? What goes into that decision making?
Yeah, so good. I mean, the question is a really good question. It relates to the first question we took, which is just understanding what you're displaying. So if you're in an environment where color is a factor, determining the difference between, let's say, a red and a maroon, there is a distinct difference in the type of quality light that you're going to actually get out of an LED versus one of your incumbent technologies. And I'll digress just for a second to give you an analogy. In the industry, when a fluorescent light is lit, its broadcast of light waves do cover basically all the color palette that you would see in a rainbow. So think of the rainbow as your color palette as you're looking up in the sky. And all the colors are visible. Some may be a little bit more vibrant than others. Fluorescent lights tend to generate more yellow light. So the coloring that you would actually see of the actual color in your space will shy towards the yellowish version of that particular color. Comparing that to what an LED does, an LED typically has a higher number of red. So again, thinking of the rainbow pattern, think of the red being more vibrant. The red is going to bring out better quality of everything just about. And the reason why that is that the best source of light in the world that we all can look up to is the sun. The sun is considered to be at 100 CRI. Many of the LED products that are on the market are roughly above 90 CRI, just above 90 CRI, which means they're probably as close to the actual sunlight that you can get. And actually, I should note that there is one other source that is very close to the sunlight in 100 CRI, and that is the incandescent bulb. But we're not talking about an incandescent bulb in these applications. It doesn't have the firepower to be able to generate the light that we need for high bay applications. So getting back on topic, so LEDs can generate a better quality of the color bands, and thus you get a better quality of the actual color that you're seeing through those eyes, through your eyes. So the determination largely is, if you're a warehouse with a bunch of brown boxes, then I wouldn't recommend a high CRI whatsoever. If you're in an environment where, let's say, you're in a warehouse-looking building that maybe be an auto dealership, as an example. Auto dealerships use a lot of high bay products. High bay showroom product should be a high CRI, because when you have somebody walk in and see a blue car or a red car or a white or a yellow, you're going to want to know that that is exactly the color you're going to see when you're outside in the sun. So those are really critical steps to consider.
Thank you. So you just mentioned some specific applications again, and we had a question here. What products does Cree have to replace the older technologies in the industrial spaces you've been talking about and high bay spaces? And then also if you can tag on, if you have time to tag on any lighting, office lighting products, but mainly the question is about the high bay products available.
Yeah, sure. So, I try my best not to be so, corporate-minded here, but if the question is direct, I'll give you a direct answer. So in the Cree product family, there are a number of products actually that we would consider for high bay applications. One is referred to as the CXB, and that product is a great fit from medium bay to, let's say, high bay up to around 40 feet. If you have a scenario where above 40 feet and or your temperatures, depending on your environment, you have very high temperatures. You're in manufacturing, as an example, and your temperatures are above 45 degrees Celsius, then the product we would recommend is called an HXB. It's a larger, more fit product for those categories. We also have other products that might fit some of your needs that are more stylish. We have products that are referred to as a CPY, which some individuals would identify as a canopy fixture. And when you think of canopy lights, think of when you're pulling underneath a gas station canopy and you're pumping gas. That's a canopy light, but those lights are sometimes 20 feet above your head. So we have done installations of the CPY within internal installations. So that's kind of the high bay conversation. There may be others that we would consider positioning, but I think that's enough for that part. For office spaces, Cree does offer a whole complete line of indoor products. We have troughers, we have downlights, we have linear lights, we have linear drop cord lights, we have stairwell lights. Certainly, if you go to our website, you actually will see the breakdown indoor and outdoor clearly on the pages. But thank you for the question.
Great, thank you. And I think we have time for one last question, and then we'll be wrapping up. I want to thank the attendees for sending in all these great questions. And if we haven't gotten to your question, please be assured that John and his team will get back to you. The one last question I would like to ask is regarding utility company rebates available for these lights. What kind of trends are you seeing around the utility company rebates for LEDs?
Yeah. Boy, I hope that's just a wonderful question, and I'm glad it's the last question on this list, because we're at a state today where the electrical companies now are making a move to require a higher efficacy product for rebates. And there's a reference called DLC, and DLC is the Design Lights Consortium. It is basically an organization that acts on behalf of all the utilities to basically determine what kind of product efficiency-wise should qualify for some type of rebating product. And we're at a state within the industry where the expectation is that we can generate some really high efficacy products. An example would be is that very shortly, in order to get a rebate, you're going to have products that generate 130 lumens per watt or more. That's significant. Even for the LED world, that's a significant statement. Now, having said that, in the high bay world, today there are many products that are rebate available. You can, in some cases, depending on your location, you can actually get half of that particular fixture paid for by rebates, which again will be a huge factor in your payback calculations. It's generally easy to find if you go to your local utility that is servicing your warehouse or your building and just type in a search for rebates. There are two different types of rebates that are going to be identified. One of the rebates is going to be essentially mid-range rebates, which all that means is that you're going to actually be able to identify on a screen whether your particular application is going to work and qualify for a rebate. There's others that you actually have to submit a request for a rebate, but really great question, a great way of moving your products or moving your environments to an LED world. Take advantage of these now because, like I said, very shortly, the utilities are going to be pressing upon everybody to buy a higher lumen package. Generally means a little bit higher costs, too, because it's a little costlier to develop those higher lumen products. So act as soon as you can.
Great. Thank you very much, John. Looks like we're out of time. I thank you for the presentation. And I thank Cree for sponsoring. Yes, thank you. And I thank Cree for sponsoring the webinar, and of course our audience for attending today and for sending in all these great questions. A recording of the webinar will be available online at facilityexecutive.com as well as on the Cree website at cree.com. Thanks, everyone, and have a great afternoon.